Drag the reactants and products of the chemical reaction to either side of the scales. What do you notice? Answer: the scales is balanced. In a chemical reaction, we assume that mass is conserved. This is true as the energy released is comparatively small and the change in mass is too small to be detectable. Click the Next button. Now drag the reactants and products of the nuclear reaction to either side of the scales. What do you notice? Answer: the mass of the reactants is greater than the products. In a nuclear reaction, the energy involved is so great that the change in mass is no longer negligible. One can no longer assume that mass and energy are conserved separately. Einstein explained the loss of mass or mass difference in a nuclear reaction in his famous theory on interconvertibility of mass and energy. He stated that the principles of separate conservation of mass and energy must be combined into the conservation of the total of mass and energy. Mass can be converted into energy and energy into mass by the relationship E equals mc squared. How much energy is dissipated if 1 kilogram of mass is converted to energy? Answer: E equals mc squared equals 1 times 3.0 times 10 to the power of 8 squared equals 9.0 times 10 to the power 16 joules. An average person in a developed nation uses about 5 times 10 to the power 11 joules of energy in a year. The energy dissipated by 1 kilogram of mass is sufficient to supply 180,000 persons for a year. For calculation of energies involving nuclear reaction, masses of the nuclei are usually given in terms of the atomic mass unit U. Calculate the energy released during the alpha decay of uranium-238. Click through the steps to reveal the solution. Summary: in nuclear reactions, the principle of conservation of mass and energy must be combined. The energy released in a nuclear reaction can be calculated from its mass difference. Mass can be converted into energy and energy into mass by the relationship E equals mc squared.